Okay, just going to look at angles of any magnitude. Now the word magnitude just means size. So we're looking at angles of any size. So we're not just looking at like acute and obtuse angles, we're also looking at reflex and, even angles that just keep turning. So you go around once, 360, around again, so, 60, 120, 240, 300, you could have 420, spin again, 600, okay? So spinning all the way around. So just want to look at those angles of any size. Now, when we look at those angles, first of all, we can break it up into quadrants. So the first thing I want us to look at is if we look at quadrant 1. So if we base this once again on a unit circle just means that the radius is 1. And we look at that then, and if we look in quadrant 1, okay, we just call that angle theta there. So when we look at this triangle here, we draw a right angle triangle. That's the y value, that's the x value. It's a unit circle, so that means that the radius is 1. So when we're looking at this then, that means that tan theta is equal to the opposite on the adjacent, so it's y on x. And you notice the x and the y value are both positive. So tan theta in that quadrant will be greater than 0 or positive. If we look at sine theta is y over 1 because it's opposite on hypotenuse. So sine theta will be positive in quadrant 1. And if we look at cos theta is equal to x over 1 adjacent on hypotenuse, which is also positive in that quadrant. So in that first quadrant, all sine, cos, and tan are greater than 0. They're all positive. Now, if you look now at quadrant 2, so we're looking at quadrant 2, to actually get to quadrant 2, you spin this direction. So that's 0, that's 90, that's 180. So you go to like an obtuse angle. So in that quadrant, if you look at that, the x value is negative and the y value is positive. And that's 1 on top there. So if you look at sine theta, sine of whatever this obtuse angle here is. Now, just one other thing too. On this one here, the angle is just theta. With this, it's like having 120. The little acute angle that matches it would be 60. So we say in that quadrant there, it's actually going to be 180, take away the theta. See, theta's just the little acute one here. And this here is 180 minus theta because that there is just a straight line. And to get to the actual angle, you go 180 and you take away theta, and there you go, you're at that line there. So instead of writing sine of just theta, it's really sine of the obtuse angle, which is 180 minus theta. Now in that quadrant, sine is going to be opposite on hypotenuse, which is y over 1, which is greater than 0. It's positive. We're just looking at the signs. Like in quadrant 1, they're all positive. In quadrant 2, sine's positive. Okay, but if we look at cos of that angle there, or cos of 180 minus theta, cos is equal to, even if we're just looking at that acute angle, in that quadrant there, it is y on minus x. Okay, oh sorry, not y on minus x, it is minus x, that's the adjacent, on 1. And you can see that's negative. So it's going to be cos in that quadrant will be minus x on 1, which will be less than 0. So cos is actually negative in that quadrant. So sine is positive and the cos is negative. Just get your calculator and put any obtuse angle and do cos of it, and you'll see that it will always be negative. But if you took the same angle and you took sine of it, you'll see that it is always positive in that quadrant. And it's always positive because the opposite is a y value, which is positive, and the hypotenuse is 1, which is positive. But with the cos, the adjacent is minus x, and the hypotenuse is 1, which is negative. Okay, so we've looked at sine, we've looked at cos. Let's look at tan in that quadrant. So if we did tan of theta, and we're just looking at that small little one, or we write it as tan of 180 minus theta, like an obtuse angle. In that quadrant, tan is y on minus x. Y on minus x, because the adjacent side is minus x, and minus x, that means that it will be negative. So that means that tan in that quadrant is less than 0. And the same as cos. If you got tan of 120, tan of 110, tan of anything that is in that quadrant, so between 90 and 180, you'll find that you always get a negative value. So tan of 120 equals minus 1.73. So it is negative. So far, what we know so far with this, we know that when we have our circle and we have our unit circle and we're turning it around, so far we've hit quadrant 1. Now quadrant 1, that would just be theta. And we know that they all of them in quadrant 1, all are positive. If we go to quadrant 2, and we come around here, the little acute angle's there, but to get to that angle, it's 180 minus theta in quadrant 2. There's 180 round to there minus theta. In that quadrant, sine is positive. So in quadrant 1, they're all positive. In quadrant 2, sine is positive, but tan and cos are both negative. So sine only is positive. So this is quadrant 1, 2. Now we're going to look at quadrant 3. What happens in quadrant 3? Okay, so in quadrant 3, so to get to an angle in quadrant 3, we go 180 and then we go a little bit more, so we go plus theta. And that's your triangle there. So let's just enlarge that a little bit. There's your theta, 180 to there. So to actually get to that angle, it would be 180 plus theta. Okay, now in that quadrant, the x is a minus x, the y is a minus y. So we're interested in looking at the sine of anything in that quadrant. So sine of 180 plus theta, it's the same as having like sine of 240. That would put something in that quadrant. Or sine, something bigger than 180 but less than 270. Because 270 there's 180's there. So sine of 200. You put any of these values in, you will find that the sine value, see it's going to be minus y, because that's the opposite on the hypotenuse, over 1. The sine will be less than 0. Okay, let's look at cos, because minus y on 1 is negative. Cos of 180 minus theta, that would be adjacent on hypotenuse. So the adjacent side in this triangle is minus x. So it's going to equal minus x and 1. So it's less than 0. And tan of 180 plus theta, tan of 180 plus theta is minus y on minus x, which gives you positive y on x. So tan in that quadrant is positive. Tan's the only one that's positive. Okay, so far now, they're all positive in that quadrant. Sine only is positive in that quadrant. The other two are negative. Tan only is positive in that quadrant. This is theta. This is 180 minus theta. This is 180 plus theta. Now we have to look at quadrant 4. So what actually happens in quadrant 4? So you put the theta there and you go, all right, that's 360 minus theta. So it's 360 minus theta to get to that quadrant there. Okay, so if you look at that, that is x and that is minus y and this is 1. It's minus y because like this is positive, negative, positive, negative. So I'll look at first of all sine of that angle. So you go all the way around, that's 360 minus theta. So in that quadrant it is 360 minus theta. So sine of 360 minus theta will be minus y on 1, so it will be less than 0. cos of 360 minus theta will be positive x on 1, which is positive, so it's positive, and tan of 360 minus theta, tan will be minus y on x, which is less than 0. Okay, so the only one that's positive in this one will be the cos. So in that quadrant, it's only the cos that is positive. So just in summary, if we have our unit circle, all of them are positive there. So that means all positive. That's sine, cos, or tan. Sine only is positive. The other two are negative in that quadrant. Tan only in that one. And cos only in that one. So it got quadrant 1, 2, 3, and 4. So it goes 1, 2, 3, and 4. So in this quadrant here, the angle was just theta. This one here was 180 minus theta, 180 plus theta, and 360 minus theta. So basically, I mean, you got sine theta, cos theta, tan theta. That's quadrant 1. Quadrant 2, you have sine 180 minus theta, cos 180 minus theta, and tan 180 minus theta. So sine 180 minus theta is equal to sine theta, because we know in that quadrant sine is positive. And when we're looking at these angles, like the triangles will go like this, okay, and the little angle in there, that's your theta, just in there. So it's equivalent to that acute angle there, but it will be positive in that quadrant. Cos will be negative in that quadrant, so it's minus cos theta, and tan will be negative in that quadrant. If you look at quadrant 3, that's quadrant 1 and quadrant 2. Quadrant 3, sine of, it's 180 plus theta, will equal negative sine theta. Cos of 180 plus theta will equal negative cos theta. And tan of 180 plus theta will equal a positive tan theta, because tan's the only one that is positive. And in quadrant 4, sine of 360 minus theta is negative sine theta. Tan of 360 minus theta equals minus tan theta, and cos of 360 minus theta equals cos of theta, because in that quadrant only cos is positive.